Okay, so just picking up where we left off in the last video, applying my function. So that's going to be 16 minus 1 squared plus 16 minus 2 squared times 1. And what that's 15 plus 12 times 1, which is approximately 27. And now these rectangles were too tall, so here's an overestimate. But again, it's the process that we want to, the actual computations, and when you do these problems on your own, the computations can get nasty. And if you find yourself making stupid little computational errors, do not worry about that. That is not the point of this. We're laying foundational work here. And what we want to get is we're estimating areas by adding up individual rectangles, areas of rectangles. Now the previous problem, we got 19, and that was an underestimate because our rectangles were a little too short. Here we got 27, that was an overestimate because our rectangles were too tall. And so we could compare both of them, and we now know that the exact area is somewhere between 19 and 27. Now that's not a particularly good estimate. There are a whole lot of numbers between 19 and 27. Well, actually, there are infinitely many numbers between 19 and 27, but that's a fairly large distance there. So it's not a good estimate. So then we talk about ways we could get a better estimate. And again, I'm talking to an empty classroom here, getting ready for a pandemic, or we are in a pandemic, so getting ready for whatever may happen, trying to get ready for whatever may happen. And so I looked to the class and I said, well, what could we do to get a better estimate? And someone that's had Calculus 1 before always tells me about trapezoids. Well, you could use trapezoids. And yeah, trapezoids do a better job, but we want to stick with rectangles. So if we're going to stick with rectangles, the way we could get a better estimate is to use more rectangles. Because if I use more rectangles, this spot right here where it was a little bit too big, those over and under areas, they get smaller, and so we get a better estimate. So the more rectangles we use, the better estimate we get. So that's what we're going to see in the next problem. Same function. Using finite approximations, estimate the area under the graph f of x equals 16 minus x squared between x equal 1 and x equal 3 using a lower sum of 4 rectangles of equal width. So we're going to do basically the exact same thing, but with 4 rectangles. So again, delta x equals the width of the rectangle, always given by b minus a over n. And so in this case, 3 minus 1, because that's the interval that they've told us, so there's where I'm getting my b and a values, the interval that they told me to be on, b minus a over, or 3 minus a over 4. So 2/4 or 1/2. So there's the width of each rectangle there. Then draw our picture. So again, we're going from 1 to 3. Rectangles of 1/2 unit. So the first rectangle is just going to be right there, 1/2 unit. Lower sum. So our rectangle should be a little too short. It should meet below the curve. So trying to draw a straight line here. There's what the first rectangle is going to look like. There's rectangle 1. Rectangle 2, 1/2 unit. So this was 1 right here, then that was 1/2. Then 2, again a lower sum, so it meets below. So there's rectangle 2. 1/2 unit, so that right there would be 3 halves. No, that would be wrong, because we started at 1, excuse me. So let me redo this. So that's 1. This would be 3 halves. That would be 2. This next one would be 5 halves. So there's my base. Meet below the curve. And so there's my third rectangle, and the same thing on the end, 1/2 unit, so it goes right there. That x-coordinate's going to be 3. Meets below. And so there's my picture. And so S1, S2, S3, S4. Don't try to do these without a picture. The picture actually does help. And so the area is approximately equal to the area of S1 plus the area S2 plus the area S3 plus the area S4. And each time, it's height times width. So height 1, I'm not going to write out the whole word, height 1 times width 1 plus height 2 times width 2 plus height 3 times width 3 plus height 4 times width 4. But in this case, since we said all the rectangles have equal width, I could have just as easily on that previous line said delta x. The only reason I didn't is because I wanted to emphasize that the width of that rectangle is given by delta x. And I wanted to try to put that into your brain, that width is delta x. Now all those heights, we go back to my curve. There is where the height of S1 is. The x-coordinate is 3 halves, so that's going to be f, 3 halves, f of 3 halves. So height 1 is f of 3 halves. Delta x. Height 2, that doesn't look much like 3 halves. Height 2, right there. The x-coordinate is 2, so this is 2, f of 2. The y-coordinate gives me my height, so my height is f of 2. Height 3, right there. My x-coordinate is 5 halves, so that's going to be 5 halves f of 5 halves. And so my height is the y-coordinate, so f of 5 halves. And lastly, my last height right there, the x-coordinate is 3. That makes the y-coordinate f of 3. Remember, you always get y-coordinates by just plugging into the original function. So my y-coordinate is f of 3, and that y-coordinate gives me that height right there. And so my height is f of 3 delta x. And it really is downhill from here. I can factor out that delta x. And then I can recall one more time that f of x is 16 minus x squared. And delta x in this case is 1/2. And now we just start doing lots of arithmetic. So that's going to be 16 minus 3 halves squared plus 16 minus 2 squared plus 16 minus 5 halves squared plus 16 minus 3 squared, all times 1/2. Now starting to do my arithmetic. And the point is not the arithmetic. So hopefully I get it right, but if I get it wrong, you'll excuse me. So that's 16 minus 9/4 plus 16 minus 4 plus 16 minus 25/4 plus 16 minus 9, still times 1/2. So what do we got here? 16 plus 16 plus 16 plus 16. I got 4 16s there. That's going to be 64. Negative 9/4 minus 25/4 would be negative 34/4, we hope. This is where I miss having students in a classroom. If I do my arithmetic wrong, someone would call me on it. 1, 2, 3, 4 16s, that's 64. Negative 9 minus 25 is negative 34, so negative 34/4. Negative 4 minus 19 minus 13 times 1/2. 64 minus 13 would be 51 minus 34/4 minus 1, which would be, getting a common denominator, 204/4 minus 34/4 times 1/2. Getting a common denominator there. Yeah, I'm pretty good with that. And what, that would be 70/4? No, that would not be 70. How about 170/4 times 1/2, which is 85/4, which is, to get a better decimal to get a better idea of what we've got, 21/25, which corresponds to what I see on the next page. So we did our arithmetic correctly. Again, point not the arithmetic. So all this arithmetic here, that was just me doing my arithmetic successfully. I gotta admit, I'm impressed that I did it successfully. But the point is up here. The point is this concept, that we can estimate the area by filling that region with rectangles. Here we filled it with 4 rectangles, did height times width on each rectangle, did my arithmetic, and we came up with 21.25 square units. Being a mathematician, or math person, I'm not a mathematician, I'm just a math person. I don't care that much about units, but if my tick marks were measured in centimeters, this would be 21.25 square centimeters. But my rectangles here were a little too short, and so this would be an underestimate. Now, we could do this yet again. We're not going to, but we could do it again, this time with an upper sum. And if we did it with an upper sum, we come up with 25.25. And so then putting those two things together, we get now that the exact area is 21.2, the exact area is somewhere between 21.25 and 25.25. And so we did make a much better estimate when we went to 4 rectangles. 2 rectangles was between 19 and 27, 4 rectangles, 21.25 and 25.25. And so the idea here is that we could get better and better estimates by doing more and more and more rectangles. That's the idea we really want to take away. And that ends this section.